Now, when we understand the derivative, we can consider the inverse operation, and that is integral, a very, very important term in mathematics and applied sciences. There are several types of integrals, and we will start with two. We will start with indefinite integral and definite integral. Indefinite integral has many synonymous names. It is also sometimes called antiderivative, inverse derivative, primitive function, or primitive integral. Well, surprisingly enough, definite integral has not so many alternative names. Well, when we talk about the language, integral is not to be confused with integer. Two similar terms. Integer is a number that is rounded, that is whole, like -3, 2, and so on. We have set the set of all integers, right? So this is integer number as an opposite of fractional value. So this is integer, but we don't mean integer, we mean integral. Okay, so let's start with some simple example. Imagine the function x squared, and we know how to differentiate. The derivative of x squared is 2x. And now the question is, what is the function such that its derivative is 2x? And this is called the indefinite integral, namely antiderivative. That means the inverse of the operation of differentiation. Previously, we usually denoted the original function small f, and we denoted the derivative as f prime. Okay, that is often used when talking about derivative, and when talking about integrals, we usually denote the original function, capital F, and we denote its derivative, f prime, small f. And then, if this is true, for all x in some interval, interval is an important term. That means a continuous piece with no holes, no missing points, everything between 2 points. So this is an important point. So if we have two functions, small f and capital F, such that the derivative of the capital F is equal to small f for all x in some interval, then this is the definition of the indefinite integral of the antiderivative of small f. And we write this integral of f x dx is capital F of x. So, using the previous example, we could write that integral of 2x dx is equal to x squared. This symbol comes from the letter s, that comes from the term sum. That means if we add many contributions. This is the function that we integrate, that we antidifferentiate. And dx is just a symbol to denote the variable. Later we will see the reason for this notation. For the moment, you can think of this symbol and this symbol as sort of brackets, and inside we write the function small f that we integrate. So this is the definition of the indefinite integral, and definite integral is when we write some values, some numbers below and above the integral sign. And then by the definite integral we mean the antiderivative at this number, sometimes called upper limit, minus the antiderivative, capital F, at the lower limit. So this is the definition of the definite integral. Well, practical-oriented people like engineers, chemists, physicists, usually if they have a problem, they ask what is the solution of the problem. Mathematicians consider this as only the third question. If a mathematician has a problem, he first asks, is there a solution or not? If so, if there is a solution, is there just one solution? Then we call it a unique solution. Or are there more, 2, 3, 5, infinitely many solutions? And only then, sometimes, he asks, what is the solution? So if we want to find the antiderivative, the question, is there a solution? Is there a function? Yes, if f is continuous, then the antiderivative exists. That was the first question. Now what about uniqueness? Is x squared the only function with the derivative being 2x? I suggest you stop the playback for a moment and think over this question yourself. Is x squared the only function with the derivative being 2x? Stop the playback. Okay, now you can again continue. I hope you have solved the problem. No, this is not the only function. If you consider x squared plus 7, then the derivative is again 2x. And there's nothing magical about 7. Actually, any constant c, if added, then it disappears in differentiation. Graphically speaking, if you have the function x squared, then the derivative has the meaning of the slope of the tangent line. But if you add a constant, positive or negative, then if for some x the tangent has some slope, then if you shift the graph up or down, then the tangent is shifted by the same amount, but the slope of the tangent, when shifted, is not changed. So the derivative does not change. Or you can prove this from the definition, right? So we could write that the result is not just x squared plus c, where c is absolutely any real constant, maybe even complex, but we work with real numbers today. So the antiderivative is not unique. There is always a class of functions, a family of functions, that differ by a constant, and nothing more, just an additive constant. So that was the definition of the indefinite integral, of the definite integral. And sometimes we write this in the form that we write an antiderivative, and we close it into square brackets, and we write a and b here. This is just another notation, another symbol for the same expression, fe minus fa. So if we want to practice the definite integral for this function, that's an integral from 1 to 3 to x dx, we find the antiderivative, which is x squared plus c. But in the case of the definite integral, we don't have to write the additive constant, because if you add some c here and some c here, that when you subtract, the additive constant disappears. So we don't write it. And we copy the limits from 1 to 3. And then we evaluate the capital F, the antiderivative, at the upper limit b, which is 3. So we have 3 squared minus, and we subtract the antiderivative at the lower limit, 1 squared, which is 9 minus 1, which is 8. So we have an important result, that the Indefinite integral is a function, and the definite integral is a number, a value, a constant. There is no x in the result. Here the x stays in the result, it's a function. And then the name of x, if you change it here and here and here, the name of x is not important. The equivalent line could be, say, integral of 2t dt would be t squared plus c. So the name of the variable is not important. You will see many thousands of applications of integral in everything that you will learn in this university.